This is a task that has been given me on intern Shala. So it was to create a small agentic AI agent that is automatically picking the data either from the CSV file or from the doc file. This all is basically decided by the LLM. So the first package that has been created that is a CSV actor in which it is trying to create a small automatic data frame if it is not present. So I created a small data frame that is containing widget A, B, gadget X, and the service that is analysis. These are the price of each widget. Okay. Then we have a function that is lookup. So lookup is basically used to check or retrieve the data from the CSV, or you can say the data frame that we have. It would be returning us the value in the lower form, and if it is not found, then it would be setting it as return as an empty. Then we have that is agent controller. So agent controller basically consists of looking for that is having a lookup or run query. You can say a run query function that is basically used to decide or basically retrieve the information from the CSV file, either from the CSV file or based on the knowledge base. If the action matches the knowledge base, then it would be using knowledge base. Else, it would be returning or looking up for the from the CSV. Then we have these all doc file that is having some knowledge that is about the widget A, widget B, and returning policy. Then we have the price CSV that has been created by the CSV actor. Then we have evaluation. Evaluation is basically some test queries that are being set over here. So we would be one by one running these. Based on this, the LLM would be deciding if we basically need to look over the CSV file or the you can say the doc file in which we want to search. Now we have the LLM reasoner. LLM reasoner basically uses OpenAI API key that is being set in the .env file to hide the env. For that we use get.env, and load.env is basically to retrieve the env or to retrieve the API key from the .env file. The LLM model we would be using is GPT-4o mini. Uh, so this is a chat prompt template that we have decided. We are just fine tuning, or you can say we are just giving the prompt to the system that is you are an intelligent assistant to decide the best course of action to answer as a user query. Okay. You have access to knowledge base and external tools that at an external tool that is lookup. Okay. If the query is about asking the price, you need to decide use tool. Okay. If you are asking about the product pricing. Okay. If the retriever knowledge base can be answered from the query, decide use, it would be giving us output as in use knowledge base. Okay. We have also told the model that the output should be strictly user tool or use knowledge base. Okay. We specifically set the tool that we want to use as an use tool or use knowledge base. Then the query that we would be passing in and retrieving the knowledge base snippet. Okay. Then we have LLM reasoner. We have set up the LLM model that would be acting as an LLM reasoner. Okay. This is the function that is created to basically pass on the content that is the system message to the LLM and the output that we would be getting. Temperature has been set to 0. That means we strictly want the same answer all the time. We don't want any randomness in the answer. Then we have created a decide action that is basically deciding the action based on the output that we are getting from the LLM. If it does not matches, then we would be giving an error that would be parse with draft answer raw. Okay, we would be directly passing on the raw answer. Then we have the utils. Util is basically setting up the cosine similarity function and embedding that we would be using from the OpenAI. The embedding model that we are using is text embedding 3 small that was mentioned in the requirement or the instruction that we have got from the uh, in the doc file. Then we have vector store. Vector store is basically, it was given that we can store hard coded vector storing. That is, we would be creating a list storing all the doc file in it. We would be using the cosine similarity to search the most common values that we have stored in the doc file or in the vectors. So cosine similarity is basically used over here. So we have implemented cosine similarity. This has been stored in a or been written inside a function that is search that would be taking key and ks3. Then we have the config file. Config file is basically configuring all the you can say the APIs key, the embedding model, LLM model, retriever, key value, similarity threshold. These all will be inside. Now we have the main file that has been executed to run the file. Okay. In this, we have created ensure demo docs. That is, if the demo docs are not present over there, then we will be creating our own demo docs. Okay. So the first demo doc that would be having is text A or the widget A is small. Inexpensive gadget, B is upgraded version, upgraded widget, and the return policy is being within 30 days. So if they are already present, then this will not execute. If they are not present, this would be executed and storing the data over here. Then we have the load docs, that is to read the docs and store it in a form of a list. Okay. Then these all are the execution of all the functions one by one. First, we are ensuring that the docs are present. Okay. Loads doc, we have stored them in the variable that is doc. Then we have formed the vectors. Okay. Store, this is the variable, and then similarity, similar vector store, we have executed the class over here. We are storing the docs over here, building the index. Then we are using the LLM reasoner and CSV actor. Then we will be passing on the values over there, and then try to evaluate or run the LLM reasoner. Okay, that is basically having agentic control. Let's go over there and see what it is. So it is basically deciding the action which tool we need to use. Okay. So let's try to execute this. If we run this, so the first query that we have set over there was how much widget B cost. So it basically tool lookup successful. It has used a tool lookup, that is widget B cost 299. Okay. Then we have tell me steps to upgrade widget. Widget B is upgraded version of it. Okay. This is the doc file that we have created. Then we have price of widget X. So use tool reason the query specifically about the price of X, which is not covered in the retriever knowledge base. So we would be directly going to the CSV file. Then we have price of A. Okay, what is the price of A? So it is basically the query is specifically about the price A, which is not provided in the knowledge base. Knowledge base is in this doc file. Okay, so it would be looking up the CSV file that is returning me 90 in the form of JSON, as we have decided over here. The last question is returning policy of the purchase. So the retriever knowledge base, that is the doc file, provide relevant information about the return policy. If you look at the doc, that is within 30 days, it can be returned to the seller. So this is the output that we are getting over here. It is not in the CSV. This was all the explanation about um, the small agent API that I have developed, and this is the dot requirement file these need to be installed in the env to successfully execution of this, and I am still creating this readme file. Once I have completed this, I would be uploading this or sharing this project to the HR.